Hi folks, welcome to this series of data structure. In this particular video, that is 6.1, we will try to understand the tree traversal methods. There are a few ways, few options like pre-order, in-order and post-order. We'll be discussing these traversal methods in this particular video. So first of all, we'll try to understand how a binary node is represented. In binary tree node, there are three main things. One is the data, that is this, and one is the left child node and one is the right child node. Left child node pointed to the left child node, pointed to the right child node, and the data itself. So this complete thing is one binary tree node. Also, we have to understand that every binary tree node can have either 0, 1 or 2 child nodes. Now we'll try to understand few operations which we can perform on binary tree. Like we can perform operations like traversing. Traversing is nothing but visiting a particular node and processing it. We will see this when we solve problems related to that. Then other operations are like inserting a particular node at any particular position, deleting a node, searching a node. These are the basic operations, but we will get to it when we will solve the problems related to these things. Okay. How we do binary tree traversal? There are few terminologies which I would like to introduce to you. One is when we want to visit a left child, we represent it with L. When we want to visit a right child, we represent it with R. Visiting the current node is represented with D. So we have these 6 combinations like LDR, LRD, DLR, DRL, RDL and RLD. Basically what it is saying is, in case of LDR, first process the left child tree and then process the current node, then process the right child or right subtree. Same thing with all the other combinations. But the main classification is done based on the order in which the current node is processed. That's why we are ruling out 3 combinations which we earlier discussed, and we will be discussing only 3 main important combinations, which are nothing but pre-order, in-order and post-order. You can see that D is highlighted in red, and this is the position when the current node is processed. So in case of pre-order, current node is processed before the left child tree and the right child tree. In case of in-order, the current node is processed once the left child tree is processed and then the current node is processed. In case of post-order, it is done at the end. That means first left child tree is processed, then the right child tree is processed, and then the current node is processed. Now for the example, we will use this tree. We will be using the same tree for all these combinations like pre-order, in-order and post-order. We will create, first of all, we will create this kind of node structure, and then we will try to traverse and see what is the outcome coming, what is the output for that. So here I have written this code in C#. We can do the same code in C or C++ also, but since I'm working on C#, so I thought I will just represent it. I'll just represent the same pre-order traversal in C#. So instead of struct, I am using a class. But if you notice that main 3 things, which is like data, left child and right child, these 3 things are available in this class. I hope you understand and this is how I am representing a binary tree node. That means it has data, it has a pointer to, it has a left child, it has a reference to a left child, or it has an instance to a left child, and it has an instance to a right child. In case of C code, you will be using a pointer to a left child and pointer to a right child. And I have added one function which will just print the current nodes data, that is display. Then I have created one function for pre-order, and I will be explaining this particular function, and you can just apply the same logic for InOrder and PostOrder, so you will get to know how it is working. This function is basically a recursive traversal method. If you have not watched my recursion method explanation, then please go and watch that video. It will give you more idea about that, and it will help you to understand it better. So basically what it does is, whenever the node is passed, it first prints the current node's data, and then it will try to process the left node, and then it will try to process the right node. I hope you understand. I hope you understood this. In this code, we will try to see how the pre-order traversal is done. So first of all, what I'm trying to do is I'm creating the same tree structure like this. We don't need to worry about this piece of code, because when the actual problem is given to us to solve, this data is already present in database or any other data source. But to explain in this particular tutorial, I just created a structure very similar to the image which I showed earlier, so that we can traverse through that and see what is the outcome coming, what is the output coming. I'll just explain what I did is, I created all the nodes from bottom to top. So first I created node 7, then node 6, node 5, node 4, node 3, node 2, node 1. And in node 3, I just gave the left child as node 6 and right child as node 7. In case of node 2, I gave left child as node 4 and right child as node 5. In case of node 1, I gave left child as node 2 and right child as node 3. As shown in this particular image, I just created the same structure in the code. That means first I created these nodes, then I created these two nodes, and I gave the left child node to 2 and left child node for 2, like 4 and 5, and left child node for 3 as 6 and 7. 6 as a left child node and right child node as 7. And I created node number 1, and then I gave left child as 2 and right child as 3. Now let's just try to run this code and see how this works. I hope you can see the window. Okay. Basically what I'm trying to do is I'm going to call pre-order method by passing the root node. My root node is 1. I'm passing that particular root node, and we will see how that traversal is happening. So I will do F11. So first it will take the data of the root node and it will print it. You can see on the right, you can see here it first printed 1, then it took root of left, that is root of left is node 2. Now it is calling this function, pre-order function, in a recursive manner. So it will call again the same function, but the node which is passed is now 2. You can see this is the data. So now what it will do is it will first print 2 here. After 1 it will print 2, and then again it will call left root of left. That means now 2's left is 4. It will again come back in a recursive function, it will print the data. That means it printed 1, 2, 4. Then again it will call root of left, but you will notice that root of left is null, but still it will call it. Okay, it will do like this. It will come F10. It will say that root is now null. So what it will do, it will just come out of this function. It will come back to the calling function, which is this. Okay, then what it will do, it will just call the right node of 4, but right node of 4 is still null, so it will again call that. It will find that root node is null, then it will come back to that, and then it will come out of this particular function. You can see that the printed value is 1, 2 and 4. Now it will come back to the same place where the root node was 2, and then it will call root of right. Root of right is 5. It will now call root of 5 and it will print the 5. Then it will come back to the root node, which is 1, and here it will now call root of right is 3. Now it will try to process the right child nodes. Okay, let's just come here and see. First of all it will print 3, then root of left, that means 3 ka left, 3's left, 3's left node was 6. It will come there, it will print 6, and then it will try to it will go for root of right, that means 3's right child node was 7. It will come back here, it will print 7, and once it is done, it will exit, and our pre-order traversal is complete. So when a tree, something similar to this, is given for pre-order traversal, the output is given like 1, 2, 4, 5, 3, 6, 7. That means 1, 2, 4, 5, 3, 1, 2, 4, 5, 3, 6, 7. In the earlier method, we saw solution based on a recursive method. If you want to implement the same pre-order but in a non-recursive way, then you will have to write code something like this. So what it is basically doing is it is taking the root node, and then we are using a stack to hold the nodes, so that hold the next node which we want to process once the current node is processed. So we what it is trying to do is it will first write the data of that current node, then it will push that current node to the stack, and then it will try to process it will go to the left node. And once all the left child nodes, all the current node and left child nodes are processed, then it will try to go back and it will process the right child node, and it will do this till all the nodes are visited. Okay, we will see this logic something like this. First of all, I will execute all these code, all the other things. Now it is calling pre-order non-recursive code. Okay, and it got the first root node as 1. We can see here data is 1. It created a stack, and then it went ahead. It first printed 1. You can see here 1. Then it went to the left child. It took the current node as the root of left, and then it went back in the same while loop, and it printed the next left child node, that is 2. Again added this thing in a stack. So if you want to see what all data are available, you can see in 0th position, that is the topmost position, it is 2, and bottom position it is 1. So every time data is coming, it is getting added to the top position. Next it traversed 4. Then again it went back to the left, but it couldn't find anything. So it'll come out of these things. It'll come out this while loop because it traverses the current node and the node on the left side. Now it will check whether the stack is empty or not, but it will not. It is not empty because stack has 3 nodes. So what it will do, it will first pop the topmost node, and so the topmost node is 4, and it will try to process that node's right child node, but still that node's right child is again a null. So it will come back, it will come out of it, it will again check whether the stack is empty or not. No, it is not empty, it still has 2 nodes. So it will again pop one more item. Now the node it is trying to process is 2, but 2's right child node, yes, there is one right child node, and that is 2's right is 5. 2's right child node is 5. It will now try to process that particular node. It will push that node, and it will try to go to the left of that node, but it will not find that left of that node. Stack has still 2 nodes, one is 5 and one is 1. Okay, so it will not exit. Then it will pop the topmost item, that is node 5. It will pop the topmost item, that is node 5, and then it will try to go to a right node of 5, but there are no right node of 5, right child node of 5. So it will just exit from here, and it will come back, and it will now take the last item in the stack. The last item in the stack is 1, but that has a right child node, that is 3. It will try to process that. It will push that to the stack. Now stack has again one item, that is the current node, which is 3. Now it will try to go to the left child of 3, that is 6, and it will write 6. You can see on the right side it is trying to print all this data, and once that is done, it will not find any more left child. It will come back, it will pop 6, and it will not find anything on the right side of node 6. So it will now pop 3, and it will try to process the right child of 3, that is 7. It will print 7, it will push to stack, it will go to the left of 7, but it will not find anything. It will come out, it will pop 7, and it will go to the right side of 7. So this is 7 itself, and that thing also is null. So this time the stack is empty, so it will now break, or it will come out of this while loop. And here you can write your logic of deleting the stack. So this is how you can write the pre-order non-recursive traversal method. Earlier we saw a recursive method, now this is a non-recursive method. I'll give a link to this code where you can download this complete code, and it has pre-order, post-order, in-order traversal in both recursive and non-recursive implementation. So you can just download that and try it out in your system, and it will be fun to debug and see this. In the next video, we will try to see what is level order traversal and how we can implement it with code, and what exactly that solves. And after that, we will try to solve some binary tree problems. So stay tuned, and if you like this video, then please subscribe to this channel, and don't forget to give thumbs up. Please give your valuable feedback, and so that I can improve my content and help many other developers. Thank you. Thanks for visiting.